Is the Big Bang a flawed theory? Could it be that extraterrestrial life has finally made contact with us? Has Voyager 1 proved the Big Bang theory wrong? The questions even extend to the legitimacy of Big Bang. Are we in a new kind of existential crisis? What is even going on in the cosmos? The Voyager has brought up some interesting insights. Let's find out. Voyager includes content that wasn't created in the media in which it is present. Even though the Earth is a large and beautiful place, it is nothing compared to the rest of the universe. And the two Voyager spacecraft that have traveled farther into the solar system than ever before are an extension of humanity. For nearly 45 years, Voyager missions have been a crucial component of space research, since they have given some of the very earliest and most important looks into the true status of our solar system. Cool, right? But Voyager 1 has discovered something that might prove the Big Bang theory wrong. According to NASA, the Explorer spacecraft has revealed fresh data, for instance, regarding interstellar cosmic rays. Deep within the heliosphere was found to be 3 times as intense as beyond the heliopause. Scientists integrated data from following missions with Voyager discoveries to gain a more comprehensive understanding of our Sun and how the heliosphere interacts with interstellar space. According to NASA, scientists revealed last year that Voyager 1 had captured a humming sound that was connected to waves discovered in minute quantities of gas in the largely empty interstellar space. In a statement, Nicola Fox, head of NASA's Heliophysics Division, noted that throughout the previous 4 decades, the Voyager missions had yielded important knowledge about the Sun and the Sun's impact on the solar system. The ability of electronics to function at temperatures well below their specified working range continues to confound specialists. Researchers have also discovered a strange phenomenon at the boundaries of the adjacent space group. The helios, the barrier separating the heliosphere from the interstellar medium, seems to be breaking apart at unexpected oblique angles. It is not an original concept that the heliopause's form can change. Science has determined that it isn't static during the past 10 years. They made use of information from Voyager 1 and Voyager 2, the only 2 spacecraft to have ever left the heliosphere, as well as NASA's Interstellar Boundary Explorer IBEX satellite, which examines the emissions of energetic neutral atoms, ENA, created when solar winds and the interstellar medium interact. The Voyager spacecraft provides only direct observations of these boundaries in situ, but only at a single location in space and time. Space physicist Eric Zernstein of Princeton University noted in an email to Vice that IBEX helps round out the data using the data of models that predict how heliopause will change in the future. In other words, the push and pull of solar winds in the interstellar medium creates a border that is continually moving. Nevertheless, data from more recent heliopause studies defy earlier conclusions. IBEX recorded the illumination of upper Viennas that suggested heliopause imbalances for many months in 2014, and the researchers later discovered that such aberrations were inconsistent with the negative habits highlighted by the model. Additionally, after focusing on data from Voyagers 1 and 2, researchers noticed that the heliopause moved significantly in a relatively short period of time. This explains why there was such a big gap between the 2 probes' entries into interstellar space in 2012 and 2018. However, the motion of heliopause also casts doubt on the theories. Researchers described these discrepancies as entry speaking in a paper that appeared on October 10th in the journal Nature Astronomy, and suggested that they would be disputed. In the hopes of receiving more information from NASA's Interstellar Mapping and Acceleration Probe, IMAP, a brand new satellite that will launch in 2025 and be able to detect ENAs, they intend to continue their study of the heliopause. Until then, we can only make conjectures about this strange activity taking place in the eerie recesses of our solar system. Since it entered stellar space, Voyager 1 has sent back a ton of useful data about the circumstances in this region of the universe. Among other things, it has been shown that cosmic radiation is very powerful, and that charged particles from the Sun interact with those from other stars. Voyager 1, the epic spacecraft that journeyed into the depths of our solar system, encountered a major setback earlier this year when it stopped transmitting telemetry data. With billions of miles between the spacecraft and Earth, many thought that Voyager 1's incredible mission had come to an end. However, the NASA engineers refused to throw in the towel and instead developed a groundbreaking remote diagnosis and repair system. And guess what? It worked. Against all odds, Voyager 1 is now back online and communicating with ground control flawlessly after almost 4 months of silence. Can you imagine how exhilarating it must feel to revive a spacecraft billions of miles away? A spacecraft in color with a sizable radio antenna on the left side. Radio communications between Voyager 1 and NASA engineers on Earth are sent and received using this high-gain antenna. The 45-year-old spacecraft, according to NASA's Interstellar Space Cruise, appeared to be operating remarkably well and beaming reams of data back to Earth. But in the middle of May, Voyager 1's Attitude Articulation and Control System AACS, which is in charge of maintaining the spacecraft's high-gain antenna pointed at Earth, started returning puzzling data jumbles instead of the usual reports about the spacecraft's health and status. According to our observations, the spacecraft looked to have developed something that resembled an electronic kind of aphasia, a condition in which one loses the capacity to speak clearly. In a statement, NASA clarified that while the data may seem to be randomly produced, it does not reflect any possible state that the AACS could be in. Voyager 1 appeared to be in fine condition despite the strange status reports for the spacecraft, which was even more puzzling for engineers. The receiving cable was still aimed at Earth, and not in anything that resembled the setup the AACS was claiming was into NASA in the reports, because the radio and transmission from the boat's areas of strength remained constant. Similar to this, the AACS did not encounter any of the odd phenomena that the Voyager 1 science systems did. Whatever was wrong with the AACS did not also activate a fault protection system that is designed to put the spacecraft into safe mode in the event of a glitch. Thanks to their discovery, NASA's engineers may now be able to treat the problem. It came out that the AACS started transmitting its telemetry data using an old onboard computer, and the dead computer damaged all of the outgoing data. NASA engineers only needed to instruct the AACS to utilize the right computer to send its data home. There is still a problem, though, and the next task will be to identify the precise reason that switched computers in the first place. A defective command likely entered the system from another onboard computer, according to NASA. Even though they asserted that it isn't a serious threat to Voyager 1's health right now, the real cause needs to be found and fixed to stop any further weirdness. The previous 10 years have been spent by Voyager 1 navigating into interstellar space distant from the magnetic field of our Sun. Like how the magnetic field of Earth shields us from solar radiation and high-energy particles, the vessel has gotten some protection from cosmic rays and interstellar radiation. Imagine this. Voyager 1, the 45-year-old spacecraft, is on a mission to explore interstellar space, a place that no other spacecraft has ever reached before. However, this uncharted territory comes with a unique set of challenges, including an abundance of cosmic rays and energetic particles that can cause havoc on the ship's onboard computers. These quick energetic particles can collide with a computer chip, causing minute memory mistakes that build up over time. It's like a slow and silent saboteur waiting to strike at any moment. It's no surprise then that even the project manager for Voyager 1 and Voyager 2, Suzanne Dodd, admits that such a mystery is somewhat expected at this point in the mission. The spacecraft is pushing the boundaries of what's possible and defying all odds, but it's a race against time to keep it functioning smoothly amidst the harsh conditions of interstellar space. A wonderful accomplishment of human ingenuity and scientific exploration is the Voyager mission. These satellites have traveled outside the solar system, investigating the outer planets and probing the interstellar realm. The inspiration they have given future generations of scientists and explorers will, however, be their most lasting contribution, serving as a reminder of the endless capacity of human curiosity and the boundless opportunities for scientific discovery.